Now that we have established that B is the limiting reactant, so we can say for sure that in the final state we will have zero amount of B, meaning that in the change position or in the middle over here, we are going to have -1 mole for B. Because B is limiting reactant, it has to be consumed completely by the end of the reaction. Now, what is the mole of A in the change state, and what is the mole of C? To be able to determine the mole of A, we take the coefficient of A divided with coefficient of B, multiply with mole of B. For the mole of C, same thing, we take the coefficient of C and divided by the coefficient of B and multiplied by the mole of B. So for A, we're going to get 1, which is the coefficient of A, divided by 2, which is the coefficient of B, times 1, which is the mole of B. So the mole of A in the change state is going to be half mole. All right. While for C, it's going to be coefficient of C, which is 3, divided by 2, multiply by mole of B, which is 1, and we're going to get 1.5 mole. Okay. Therefore, let's write it down here. We have in the change state the mole of A, 0.5, and the mole of C, 1.5. The reactant is going to be decreased, so we have to put minus in A, while for products, it's going to increase, so we can put plus here, or you can also, you don't have any sign, we assume that it is increasing. Yeah. So by the final state, we're going to have A of 1.5 mole, and we're going to have C also 1.5 mole, while the B is going to be consumed completely. And this is how we obtain the state or the composition in the final state. Notice in this, the one that actually follows the ratio of 1, 2, and 3 is the numbers in the change part. So it's a half, 1, and 1.5. And it's always like this. The stoichiometric ratio, you can see it in the change part. The initial part can be anything and any compositions, and you have to process them this way to be able to get the final composition. Now, one of the common goals in doing stoichiometric calculations is to be able to determine the yield of a product, and that is normally in solid phase. Now, from stoichiometric calculations, as we discussed in the previous segments, we can get the mole of the product that we expect to obtain in the final state. Now, this mole, we can convert it to the mass of the product by multiplying the mole with the molar mass, that could be the AR or the MR, depending on whether it is an atom or it's a molecule. Now, the mass that we get from the stoichiometric calculation is actually the theoretical mass, while in reality, experimentally, the mass that we got of the products is almost always lower than or smaller than the mass that we expect to get in the stoichiometric calculations. This can be due to formation of side products, or it could also be due to lower efficiency of reactions, and so on. And for this, we determine what we call the yield of the reaction by taking the mass that we got experimentally, and we divide this with the mass of the product that we calculate theoretically in the stoichiometric calculation, and multiply this by 100%. And normally the yield is always less than 100%, and even reactions that got into the yield of 90% or so, we already consider those reactions very efficient.